Hello friends, welcome back to my channel. Today's topic of discussion is the second part of ICMP v4. In the previous video lecture, I have explained you the different error messages that are sent to the source host by this protocol. And in this video lecture, I shall be explaining you about under which situations the ICMP error message is not sent. So in the previous, we have seen that under which situations the error messages are sent to the source host, but we should also know that under which situations the error messages are not required. See, if the protocol starts keep on sending the error messages for each and every small information, or wherein, like in cases where it is not required, then if the message packets are generated in for each and every kind of situation, then definitely it will lead to congestion. So keeping in view this particular problem, to avoid congestion also in the network, there can be some exemptions. Under such some situations, we may not require at all to send the ICMP error messages. So that particular thing we shall be seeing. And in the previous video lecture, I have told you that ICMP packet also consists of the header part, and what is that in the payload. What does the second part of the packet consist of? So it consists of definitely the errors that it is going to report to the source host. So errors of which datagram it is going to report. So that datagram information is also needed in the ICMP packet. So let me explain you with an illustration. Look here. I have shown you here three different packets. So the very first one is, see, first and foremost thing is the received datagram I have written here. Okay, the received datagram is what? IP header, and here will be the rest of the data. So this particular complete thing is what? The rest of the data. So this part I'll just tell you in very simpler words. What you have understood in the previous lecture is IP header and the payload. Fine. So this is what is here now. Now about this particular packet only there is some error. Then what ICMP is doing, it is taking the IP header, that is the received IP header from the received datagram, as well from the data part it is taking the first 8 bytes and it is including its header. So this is the ICMP header. So you can see here, this is the header part of the ICMP, and in the payload part or in the second part of the packet you have what? The IP header about that particular IP packet or received datagram. The information has to be sent, that is included, and also 8 bytes of information are taken from the data part. Now these 8 bytes are helpful. Why we are not taking the complete data? That is not required. But why do we want only 8 bytes of information? So this particular information is very important. This 8 bytes, normally the starting 8 bytes in the data part of IP header contains information about what? Contains information about the port numbers of the transport layer, UDP and TCP. Whether it is UDP, whether the protocol used is UDP or TCP, the port numbers information is present in the first 8 bytes of the data part of the IP header. And that information is very much needed, because see, ultimately I told you that the this one, what is that? The error messages are reported to the source host here. Okay, this is the source host. Fine. Now when the source receives the error message, it has to know that this information it has to send to the higher layer protocol also. It is receiving at the network layer. The higher layer protocol is what? The transport layer. Whether it is for which protocol is there here, whether it is UDP or TCP, it has to give the information to the higher layer protocol. So that, how to find out? It will come here in this ICMP packet, those port numbers information and the sequence number information, so that it is easy for the source to convey the information to the higher layer protocol. That's the reason 8 bytes are taken from the data part of the IP, that is data part of the IP packet. Next, now this particular packet ICMP is further what is getting encapsulated in the this ICMP is using the IP protocol here. It encapsulates, that means the message of the IP, the ICMP packet is completely getting encapsulated here. But so that's why the IP header is used. Fine. Because see, look here, even though in the network layer, fine. So I'll just make this is the network layer. Let us assume IP protocol was there and the companion to IP is ICMP. I said you in the previous video lecture, ICMP does not send the messages directly to the data link layer. Instead, it makes use of the IP layer. The message of ICMP is encapsulated in the IP packet and then it is sent to the data link layer. That's the reason it will definitely IP header is attached, and then this is the sent IP datagram to the source. So it is reaching the source as well as the source is knowing about what about the errors that are there for itself here, and also the port numbers to which it can convey the information to the higher layer protocols, and this is the ICMP header. So that is why this is what you have to remember, why 8 bytes are included in the ICMP packet. So this is the ICMP packet, this is the sent IP datagram, but ICMP packet is sending errors after it received the datagram. That means that particular host which has received the datagram has noticed the errors, and the ICMP protocol is the one which is helping here in the network layer to send the errors towards the source host. Fine, but no ICMP error messages are generated. So under which conditions? First thing is ICMP error message will not be generated in response to a datagram carrying an ICMP error message. So if a packet is having information about the errors, so we say it is an ICMP packet. For that, if there are any errors further, then for that no ICMP error message will be generated. So under this situation, no ICMP. And no ICMP, that means ICMP error message is not generated for a fragmented datagram, that is not the first fragment. It means error messages are generated only for the first fragment of the IP datagram. See, normally what the source host has to receive the errors about the datagram. If the datagram is divided into fragments, fine. If it has to know the error, one error message for one fragment is sufficient. And since the very first fragment carries what here the 8 bytes of information, and this information is needed for the source host to convey to the higher layer protocol, because this 8 byte contains about the port numbers of the transport layer, whether it is UDP or TCP. Hence, only ICMP error message, if it is generated for the first fragment, it is more than sufficient. The host will come to know about the problems, okay, about its datagram. That's the reason not sent for this. ICMP error message is not generated for a datagram having a multicast address. So if it is a unicast, it is 1-to-1, okay. That means whatever is the packet coming from the source is received by another host, fine. If the packet is received at a time to more than one host, that is multiple recipients are there, then we say it is a multicast. So 1-to-1 is unicast. Just one person communicating with one is unicast. One person communicating with many at the same time is multicast. So in the packet, if the source destination address is a multicast address, that means the packet, the IP datagram is intended what it is sent to several recipients at the same time. In that case also there will not be any ICMP error message generated. So it is mainly for 1-to-1 communication, the ICMP error messages are generated. Next is for a datagram having a special address such as 127.0.0.0 and or 0.0.0.0. So no ICMP means error messages are not generated for this special addresses. One is 127 dot. So hope you people remember my this one's one video lecture on special addresses. So these two are actually the special addresses. 127.0.0.0 with if you remember the block, it is /8, okay. 127.0.0.0. The prefix value was 8 here. So for this kind of addresses also no ICMP error. What can be the reason? See, 127, any address in this block is a loopback address. If it is a loopback address, the packet is having a destination. That means it is the source address and the destination address are the same in the packet. That means a person is sending the packet to himself or herself. That means the machine is receiving, I am sending a packet, okay, I am sending a message, the packet is coming back to my machine. So that in that case, what I have done is I have used a loopback address. So if I am receiving the message to itself, I will be knowing the error, whether I have received the message, whether I am receiving it or not. So in that case also there is no requirement for ICMP to send the error message. That's the reason for this special address also it is not used. ICMP is not, ICMP error message is not sent for 0.0.0.0. Here, if you remember, it was the prefix value was /32, 2 to the power of 32 minus 32 is 2 to the power of 0, which is 1. That means there is one single address, and this is called as this host address. The name itself is given as this host. So when do you use this host address? When a source does not know the IP address for itself, so in the source part of the packet, it is making use of 0.0.0. So in this situation also no ICMP error message is required. The reason is when the source address itself is not certain. See, normally when a source doesn't know the IP address for itself, it is sending a packet to the internet as a broadcast address and trying to find out information so that the server like DHCP server can assign an IP address to that particular source. So when the source itself is not sure about the IP address, for that, in that case also there is no requirement that this protocol will send, that is ICMP will send an error message here. So under these 4 conditions, ICMP error messages are not generated. So hope you people have understood this topic. Okay, thank you. Bye bye. Take care.